Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about example of spectral characteristics of a random process concept example. If the autocorrelation function of a WSS process is R of tau is equal to k e power minus k mod tau, show that its power spectral density is Sxx of omega is equal to 2 by 1 plus omega by k whole square. And this example also similar to previous model. Uh, I, al- I already discussed in my previous videos. Please refer that problem. That is Fourier transform of a e power minus b mod tau problem. So comparing that expression now where the a is equal to k and b is equal to k. Coming to the solution, given that the autocorrelation function R of tau is equal to k into e power minus k mod tau. So we know that the power spectral density of the autocorrelation function is Sxx of omega is equal to integral minus infinity to infinity Rxx of tau into e power minus j omega tau d tau. So now here autocorrelation function is k into e power minus k mod tau. Substitute that value into here, we get integral minus infinity to infinity k into e power minus k mod tau into e power minus j omega tau d tau. So now here mod tau, the range of the integration is minus infinity plus infinity. Mod tau mean plus or minus. So mod tau mod tau mean plus or minus, that is tau greater than 0 mod tau is equal to tau and tau less than 0 mod tau is equal to minus tau. And applying that condition into here, the RHS integral term can be arranged as k is constant, that is written before integration, integral minus infinity to 0. So minus infinity to 0 is tau less than 0, mod tau is equal to minus tau, and substitute mod tau is equal to minus tau. The exponential term is e power k tau into e power minus j omega tau d tau plus integral 0 to infinity. So 0 to infinity means tau greater than 0, mod tau is equal to tau. The exponential term is e power minus k tau into e power minus j omega tau d tau. So now here this exponential term is written as e power k minus j omega into tau d tau, and here also these two exponential terms is written as e power minus of k plus j omega tau d tau. So the first term integration is e power k minus j omega tau by k minus j omega over minus infinity to 0 plus k, and the second term integration is e power minus of k plus j omega tau by minus of k plus j omega over 0 to infinity. So in the first term substitute upper value of tau and lower value of tau, and the second term also substitute upper value of tau and lower value of tau. Substitute upper value of tau is 0, e power 0 is 1, and substitute lower value of tau is minus infinity here, e power minus infinity is 0, 1 minus 0 by k minus j omega, plus here also substitute upper value of tau is infinity, so e power minus infinity is 0, and lower value of tau is 0, e power minus 0 is 1, so 0 minus 1 by k plus j omega. So now here 0 minus 1 is minus, numerator and denominator negative sign is cancelled, and the both the terms k is the common. So therefore k is k into k by k minus j omega plus k by k plus j omega. So now take the LCM and both the terms k is the common. K plus j omega plus k minus j omega. The numerator plus j omega minus j omega is the cancel, and the remaining term is k plus k into 2k, k into 2k by, and the denominator term is k minus j omega into k plus j omega is k square plus j omega whole square. So j square is minus 1, before minus is there, minus into minus plus, therefore the denominator term is k square plus omega square. Therefore the power spectral density of the given autocorrelation function is 2k square, k into k, k square, 2k square by k square plus omega square.